So we are looking at still, when it's going up, u is not 0. So the vertical height equation can be this, or can also be v squared is equal to u squared minus 2jh. So that when we make h the subject, we have 2jh equal to u squared minus v squared. Then we divide through by 2g. So finally, we have the vertical height h equal to u squared minus v squared over 2g. So these are the expressions. This one and this one are what we can always use to determine the vertical height as the body goes up. And they are all squared and then a fraction. They are not linear. If they are not linear, then when we plot the vertical height against time, it will give us a curve, just as we saw for this. Please, are you with me?
Okay.
If we plot h against t or h against v, or we'll still have a curve because of the nature of the equation. So when it is going up, when the body is going up, its displacement time graph is this. Now, when it gets to the maximum height, it will not remain there forever. It will certainly come down. So when it is coming down, the path is also like this. So this is the displacement time graph. At this point, or at this time, the body has gotten to its maximum height. So this is the time taken to reach the maximum height. And this vertical height value corresponds to the magnitude of the maximum height. So this is the displacement time graph. And this is the velocity time graph. Showing that as time increases, the displacement also increases. This, and this time will give us this. Then because we are taking the initial position as a origin, okay, when it is returning, we are always measuring from wherever it started. Let me draw a diagram. If this is the origin and the body is going up, we are always measuring the vertical height from this. So when it is at this point, the vertical height is this. When it comes to this point, the vertical height is this. When it comes here, the vertical height is this. Now, so this is our initial. When it is returning, okay, over here, over here, over here, because we are measuring from here, there's a vertical height, there's a vertical height, there's a vertical height. We see when it is returning to be reducing in height, and that is what is being shown here. Is this, you can read it from here. You can read it from here. You can read it from here. By the time it comes here, it has reduced to, its vertical height has reduced to 0. Please, is it understood?
No, please.
Jan, Angel, what's the
Except I'm not the one.
Except this was Janice.
So we are looking at plotting the vertical heights covered by time. Okay. When the body is going up, so we have this does it for velocity time graph. And we are looking at the displacement time graph as the body goes up. For Janice's sake, I'm cleaning the whole thing and starting. Janice, you pay for that.
Yes, please.
So the displacement time graph, a graph of h against time. And the equation to be used in calculating that is this. When it's going up, u must be maximum so that it decreases with time. So if you are looking for any vertical height covered by the body, it must be h is equal to ut minus half gt squared. And this equation, when you plot, put in figures, will give you a curve, just as we got for free falling here. So this will give you a curve. And so when you are plotting the displacement time graph, now the body is going up. Let's assume this is the surface of the earth. So you are measuring, you are taking the origin at the starting point. Let's assume this is the surface of the earth. So you are taking the origin as a starting point, and then also taking vertically upward direction to be positive. So this is how you take your measurement. When the body is here and here, let's only do it for 3 positions. If the body is here, I'm calculating for the vertical height reach. This is it. From the ground or my initial point to this. So this is the vertical height h. When it is here, it is from the same thing to this. When it is here, this is it. If we go on and on and on, okay? And plotting h over t because of the equation will give you a curve. So this is how the graph is. Curvy to a maximum height where velocity is 0. Now, when it is coming down, of course, when you throw an object, it will never suspend in the air. No matter the height it will reach, it will come down. So when it is coming down, what happens to the vertical height covered? So when it is coming down, assuming the body is here, we are still taking a reference measuring point from the surface of the earth. So this is it. When it's here, this is it. When it's here, this is it. So what happens to the height, vertical height, as the object drops to the ground? Janice. Janice.
Mr. Hackman.
I see Mr. Hackman. Am I Mr. Hackman?
Sorry, Mr. Dia, sorry.
What happens to the vertical height as the object drops to the ground?
Please, it reduces or it comes down.
So it reduces. So when you plot the graph, you have another half curve. So this is the displacement time graph for a body thrown vertically upwards and coming down. And this is the velocity time graph. Come and call me Mr. Hackman again.
Sorry, Mr. Dia.
I won't mind you. So this point is the maximum height. This is the time taken to reach the maximum height. All right. The acceleration time graph is also a horizontal line. Of course, when it is going up, it's decelerating. So it will be along the negative. So its acceleration time graph is vertical acceleration E against time. But the acceleration is constant due to gravity, but it's negative. So it will be along the negative axis. So this is minus G, the acceleration time graph for an object thrown vertically upwards. Safo, Angel, Janice, are you okay?
Yes.
Yes, sir.
All right. Are you done writing? So I clean the board. Can I clean? Now let's look at some standard relations for vertically upward motion. Standard relation or formula. Standard relations. And this is reserved for vertically upward motion. When we talk of standard relations, we are talking about standard or some known formula. It's about formula. Okay, we are saying that when a body is going vertically upwards, when it gets to the maximum height, the initial velocity is 0. So at the maximum height, V is equal to 0. So if velocity is 0 at the maximum height, then if you use equation 1 of vertically upward motion, V is equal to U minus GT. At maximum height, V is 0. So if V is 0, then put 0 in place of this V. So we have 0 is equal to U minus GT. Let's make this side the subject. So Angel, make T the subject for me here. Angel,
Yes, sir.
I said make T the subject.
Okay. Then please, it's going to be this order. T will be equals to U over G.
So T is equal to U over G. And this is
Yes.
said to be the expression for determining maximum height time taken to reach the maximum height. Or you can also say that U is equal to J times T. If you are given the time taken to reach the maximum height, when you multiply that by J, gravity, acceleration due to gravity, you get the initial velocity given to a vertically upward body. So this is one of the standard formula. Please, are we okay?
Yes, please.
So what the application of this is that when a body is thrown upward and you have to calculate for the time taken to get to the maximum height, just divide the initial velocity given by gravity and you'll be smiling. Okay. What about the body is thrown from here and got to this point? I want the maximum height it could reach. The maximum height h it could reach. What is that simple formula for determining it? Okay, so when I consider the equation v squared is equal to u squared minus 2gh. We are saying that at the maximum height, there's a particular condition. What is the condition at the maximum height? What's the condition at the maximum height? What's the condition at the maximum height? Hey, is everybody gone? Hello?
Said yeah.
Hey, I'm asking you a question. Nobody is talking.
Say please. He said the condition for
I said, what is
the
the
condition.
condition at the maximum height? When the body is going up, what happens at the maximum height?
The velocity comes zero.
The final, Safu, are you there?
Yes, please.
I hate silence in my class. You express your view and get it wrong than to remain silent. If you are silent, I'll have problem with you, please. Janice and Angel, over to all of you. You make the attempt and get it wrong. But to be quiet, I forbid it. Is that okay?
Yes, sir.
The condition I said is that at the maximum height, final velocity v is zero. That is what I asked. And sometimes I ask these things so that it will be on your lips. I wouldn't be the only one saying it, but you will be speaking the same language with me. That's why I repeat some of these things. So at the maximum height, we know v is zero. If v is zero, I want you to make h, put 0 for v here, and make h the subject for me. Janice, I'll take your answer. You will tell me what you had. So
Said,
substitute 0.
H the subject.
But make H the subject. Are you true?
Said, please add U square over 2G.
Exactly. So you have H is equal to U squared over 2G. And this is the relation, or what you will call as the formula for the maximum height reached. So if a body is thrown to go up and you are looking for its maximum height, all that the relation is saying is that the square the initial velocity given to the body and divided by 2 times the gravity, and that will be the maximum height. The other equation we can derive from this is that we can also say that U squared, which is equal to 2GH. So when you make U the subject, you have square root of 2GH. This is the other equation you can make out of it. But this is the expression for the maximum height reached. Please, any question? Any question? Okay. Another way of obtaining the same relation for maximum height is this. I'm giving you the other way out of determining the maximum height. You see the other equation, which is H is equal to UT minus half JT squared. The other equation of vertically upward motion. Substitute whatever the relation we have for time taken to reach the maximum height, which is this. Just substitute this. T is equal to U over J. So wherever you see T, put that there. So you have H is equal to U times U over J minus half J times U over J squared. And so we have U squared over J minus half J. This is U squared over J squared. And J squared, I know this to be J times J. And I'm doing this because of the J outside. So that when I multiply through, it can cancel out. This can cancel 1. So we have U squared over J. All that we have here is that U squared over 2G. We have U squared over 2G. We can factorize out U squared over G from each term. So U squared over G out into brackets 1 minus 1 over 2. So what is 1 minus half?
Half.
So this is half. So you have U squared over G times half. And we have that to be equal to U squared over 2G for each. So this is giving us the same relation as we had for this one, as we had here. So this is another way of determining the same standard formula. Please, are you okay? Let me get 1 or 2 questions so we solve. I'm reading the question. Are you ready? Hello. Hello.
Homestead, yeah.
Are you ready?
Yes, please.
Yes, please.
Okay. So a stone is dropped down a well. A stone is dropped down a well. If it takes 5 seconds to reach the surface of the water, if it takes 5 seconds to reach the surface of the water, I, how deep is the well? I, how deep is the well? I, what is the velocity when it hits the water surface? I, what is the velocity when it hits the water surface? Take J to be equal to 10 meters per second squared. Take J to be equal to 10 meters per second squared. Are you okay?
Yes,
Are we
sir.
on question 2? Can I go ahead?
Yes, please.
Yes, please.
A rocket is fired vertically upwards. A rocket is fired vertically upwards and reaches the height of 400 meters. And reaches the height of 400 meters. I, what is the velocity of projection of the rockets? I, what is the velocity of projection of the rockets? Then I, how long does it take to reach the maximum height? I, how long does it take to reach the maximum height? So give it a try. Maybe 3 minutes to each question. So you know I'm giving you 6 minutes. Let's see what you can do. Okay. Okay.
Yes, please.
Okay.
Three minutes. Okay, your time is up. Hello.
Hi.
Were you able to do it?
Sir, please,
Eh?
I'm not done this.
Hurry up,
Sir,
hurry
please,
up,
I'm on the second question.
hurry up.
I got
You got
how
what?
deep the well is. I got 125 meters for how deep the well is for I. And I I
Mhm.
I had 50 meters per second squared
Then
for the velocity.
50 meter per second squared, right, for velocity. Velocity is
Yes,
meter per
sir.
second. There's no square.
Yes, sir.
And Safo, what did you also make for how deep the well is?
So please, for the I got 125 meters. Then I got 50 meter per second square, per second.
Okay, so what about then there's no need of solving it with you because you all had it right. Okay, then the second question. A rocket is fired vertically upward and reaches a height of 100 meters. So height reached 100 meters. And okay, so what is the velocity of the projection of the rocket? So what did you make for this?
So I couldn't do that one.
Angel, what did you make for this?
Sir, I also couldn't do it.
How long does it take to reach this height? Savo.
Sir, I tried to solve it, but I got zero and it doesn't make sense to me.
That's it. Then Savo, you too. Or what you had also never made sense to you, Savo.
Yes, please.
Okay, so a rocket is fired vertically upwards and reaches the height of 100 meters. What is the velocity of projection of the rocket and how long does it take to reach the maximum height? Take gravity to be 10. So the first question it's a vertically downward question. And the rocket's second question is a vertically upward question. Okay. And you know, for vertically upward motions,
Sir, please, the first one was a free fall.
yes, and don't, Savo, you are right, but don't forget, free fall is also a vertically downward motion. All right.
Yes.
That's why I discussed the two aspects with you. Okay, so this is a vertically upward motion. So if the body or the rocket gets to the maximum height of 400 meters, what must happen there? When the rocket gets to the maximum height, what happens?
The velocity is 0.
The final velocity, don't just say velocity. At the maximum height, final velocity V is equal to 0. So if V is equal to 0, then we obtain standard relations or formula. Okay. We realize that the maximum height H max is equal to U squared over 2G. So if you have the maximum height and you have G, can't you find U? Can't you? So go ahead and solve it for me.